All right. So yeah, now this one in this video I'm using the new latest mic, and hopefully the audio will be fine now. So we are going to study about backtracking, okay? And there is no better way to study backtracking than to implement permutations and combinations, a simple algorithm for a question, okay? And usually, like these kind of questions are asked in like L2 or L3 round, and kind of like we seem to forget. But don't worry, I'll explain in an easy way. First, let us understand what exactly this backtracking is. Okay, so think of it like we go back and back to see all the possible combinations. Okay, like let's say we want to try out each and every possible combination. Okay, just to check which one suits perfectly. Okay, so we will be having, let's say, two things. Let's say a1 and a2. It can be like a string, and we want to try out all the combinations of the string. Let's say a1 is abc and a2 is def, and we want to try all the combinations like ad, ae, af, and then bd, be, bf, like this. All right, so that we can know that okay, this particular combination can happen, and if it suits, then we add it to our result, kind of like that. We go back and back to check all the combinations that are possible, and then those which suit perfectly are included in our base case, and then that recursive function stops. That is how we implement backtracking. I know it's kind of tough for you to understand, so don't worry, we'll be writing the code to understand this. So we will be writing an algorithm to generate all the permutations of a given string using backtracking, alright? And here we will recursively permute the string by taking each character and exploring its possibilities, alright? And then we will be adding current permutation to the result when no characters remain, okay? So what we will do, I'm writing the steps. First, recursively permute the string, like what do you mean by permute the string? Like we will take each and every character, take each and every character and check its possibility. Alright. Then what we will do is that current permutation will be added to result only when no character is remaining to be checked. And then third one, again do above 2 for other combinations. These are the steps. Now, how are we gonna implement this? First, let me tell you the bigger notation. So, time complexity will be worst one O of n factorial. All right, and space complexity will be O of n. Why O of n? Because of recursion stack. Like every time a function will be called, it will be already added to the call stack. That's why. Okay, guys. Now it's time to write some code. Okay, what I will do is that I'll create a function that will one second, guys. Yeah, so this is the function get permutations, and I'll be taking the string as the parameter, and this will return the array of strings. All right, an array of strings will be returned. Now what are our next steps into this? First, I'll create the result array, and this will be initially an empty array. Alright, because in edge cases you can get an empty string, so you have to return the empty array. You have to handle the edge case as well. Right? But for now, we'll be writing very simple algorithm that we will handle everything. Now, we will create a function this is actual backtracking now. Function backtrack. All right. Prefix and remaining. This will return nothing because this is only going to do operations. All right. So if remaining dot length is 0, what we will do? Result dot push prefix. Right. When no character is remaining to be checked, we will be adding to the result. Otherwise, what we will do? We will run a for loop, and here what I'm going to do is that let character of remaining, and each character of remaining, say const. Alright, what I'll do is that I'll do backtrack. Here, what I'm going to do, prefix plus char and remaining dot slice till the current iteration. Alright. Okay, yeah. One mistake we made here. We need to run this like this. Let I equals to 0. I is less than length I plus plus and like this. Alright. And slice I till like end. Alright, I plus 1. Now, let me explain what I am doing here is that I am going through each and every character of what is remaining and what will be this remaining actually. Backtrack here, nothing first, and string. The given string will be this remaining one. So yeah, we went to the first one. All right, we went to this first one. Now 0 to 0 is nothing, and after that 0 plus 1, and after that we get to the 1, so 0 till 1, and then 1 plus 1. Whatever the current character is will be skipped by us. All right, that is how we are gonna work on this. So this particular statement is written to skip the current character which has already been checked. Okay, so I will also do console.log result. Okay, so get permutations and my string will be, let's say, my name. Now if I run this code, okay, there is some error. Let me check this error. Okay, all right, so now I'm gonna run it, and yeah, so it generated all these combinations, like these will be the combinations. All right, so this is how we are gonna generate the combinations of different like the strings, or maybe we can also compare two strings and generate their combinations. Okay, like this. So this is how the backtracking works. Okay, if you get a base case or you have exceeded checking everything, then you close it. Okay, otherwise you run this, as simple as that. nothing else. Okay. So yeah, this is it in backtracking, and I'll be meeting you in the next video where we will be solving one more problem of the same backtracking only. Thank you.